Hey, what's up? It's your old pal, Mr. Cook, and we're working on the probability review. So let's see here. Stefan wants to order a personalized license plate for his car. His favorite number is 33. How many plates can you make with the first two digits being 33 and the last four are any letter? So that means that the letters can repeat themselves. This is just a simple counting principle problem. So the first thing that you have is that number 33. And then after that, you have an alphabet letter, so any letter, and then another letter, and another letter, so that's the third letter, and a fourth letter. Okay, so there's only one way to make 33 on a license plate number, that's with the number 33. There's only one way to do that. And then for letters of the alphabet, there's 26 of those, and since you can repeat them, there's gonna be 26 letters that you can choose from for each of these spaces. So all you have to do to figure out the total number of ways that you can make the license plate is to multiply these numbers together. So 1 times 26 times 26 times 26. So 1 times 26 times 26 times 26 times 26. And then you get your total number of ways that you can make the license plates, and that's 456,976 different ways. So that's the first problem. You're taking a matching test with 10 things in the options, or 10 different options. Yeah, with 10 options. That's probably what it should say. In questions 1 through 4. You want to know how many different ways you can answer the 4 questions. So we got to determine if it's a permutation or a combination. So remember, the permutations are the ones where the order matters, or like they have assigned roles, and then combinations, it's just like groups. So like if I had this question, these questions to answer for matching, I had 1, 2, 3, 4, right? If I answered A for the first answer, B for the second one, C, and then D, would that be the same? Would I get the same score if I did this instead? Like if I wrote in B for the first one, A for the second one, C for the first one, D for the last one? If you answer that this would give you a different score on the test than this, then that means that the order matters, because each individual question, if you put in an answer for each of the different questions that's different, then it results in a different score. So that means that this is going to be a permutation. So how many different ways are there? There's 10 different options, and we're going to do a permutation of 4 different questions. So 10p4 on your calculator, you hit 10, and then hit math, and then go to probability, and then it's permutation, and then 4, and then you get your answer, which is 5,040. So there are 5,040 different ways to answer those questions. Next up, number 3. The school's debate team is made up of 12 seniors, 9 juniors, and 8 sophomores. So you have a group of 9 that will be chosen to perform at the state competition. Is this a permutation or combination? Well, that kind of depends. If it just says that it's a group of 9, just the way that it is, if it's a group, then it doesn't matter. There's no assigned roles to them. So the way that it's written, it's a combination. Now it says, how many ways are there to select 3 members from each grade level? Now, this breaks it up into different subsections. So for example, you're going to get a group of seniors, a group of juniors, and a group of sophomores. So this is kind of remember I think it was like a sandwich problem where you have different breads, different meats, and different cheeses. This is the same thing. This ends up being a combination for each individual part of it. So we're going to take 3 people, a group of 3 from each of these different groups, and then after that we're going to use the counting principle to multiply all these together. So the seniors, I'm going to take 3 of those, so I've got 12 seniors, and then I'm going to do a combination of 3 of them. The juniors, I've got 9 of them, and I'm going to take a combination of 3 of those. And then I've also got sophomores, and I've got 8 of them, but I'm going to take a group of 3 of those. So I'm going to do all of these 3 individually and then multiply them all together to find the total. So let's do each of them individually. So 12, and then C3, so math, C, and then 3. So 220 times, and then it's 9 C3, so 9 C, and then 3, 84. And then 8 C3, so 8 C3, 56. So we just multiply all 3 of those numbers together, and we've got our answer. So that's 220 times 84 times 56, and that gives us our total. So that's a big number. So let's see, that's going to be 1,034,880 different groups that we can make here. So what's the probability that the group does not have any sophomores at all? Man, this is a pretty challenging probability question. So remember, it's like the desired, the number of desired outcomes for probability over the total number of outcomes. So the probability that the group does not have any sophomores, this is not talking about this one anymore, because this one has to have the sophomores. So what it's saying is that, like, we have only juniors and seniors in the group. So there's a total of how many juniors and seniors total? There's 12 seniors and 9 juniors, so that's 21 total students. And of those 21, we're going to take a group of the entire 9 from there, okay? So that's the number of desired outcomes that we have, and then let's do that over the total number of outcomes. So the total number of outcomes would be all of the students added together, so 12 plus 9 plus 8, so that's going to be 29 total students, and then taking a group of 9 of those. So this is what we would do for the probability, and then just use your calculator to calculate that value. So 21 C9 is 293,930, and then 29 C9, so 29 C9, that's a big number, 10,015,005. And then, try and reduce it as best you can. So 293,930 divided by 100,15005. Okay, so you get some decimal answer. And then I would change it into a fraction to see if it reduces, and I guess it doesn't. I know it does because these end in 5, so I'm just going to, divide both of these by 5 and see what I get. So 293,930 divided by 5. So now it's 58786 over 100,15005 divided by 5. So that's 200,3001. And then that's divisible by 3. And let's see if that's divisible by 3. 13, 20, 28, 34. No. All right, so I don't know. I reduced it as much as possible. But if you just had the decimal answer, that's probably good enough. So 0.02935. So that's about the probability that you'd expect there. Okay, so that's number 3. And then I'll do number 4 here. Given the set, so this is the universal set. A is the even numbers. Let's list off what those are. So the even numbers from this are going to be 2, 4, 6, 8, and 10. And then B, the numbers are already given to you, 2, 3, 4, 5, 6. So what's A union B? Remember that union means all the stuff together. So if we just list off all the stuff that they have listed together, so the smallest number is 2, and then after that would be 3, and then 4, and then 5, and then 6, and then 8, and then 10. So that's all the numbers grouped together. That's the union. Now for the B complement, remember that's what that little apostrophe means. So what that means is we take the numbers in B, and then we take those out of the universal set. So 2, 3, 4, 5, 6. Take all those out of there, and then list what's left. So that's going to be 1, 7, 8, 9, and 10. All right, now we have to find the intersection. So that's the stuff that two groups have in common, and it's going to be of the complements together. So let's find the complement of A. So if it's the even numbers, then the complement of A complement is the odds. So that'd be 1, 3, 5, 7, 9. And then B complement, we just found that's these ones up here. So to find the intersection of the two of them, that means that what we're going to look for are the ones that are in common. So what numbers are in common between these two groups? Looks like we got 1 and 7 and 9. So we just list off those numbers, 1, 7, and 9. And that's the intersection of the complements. So the next question is saying, what is the complement of the intersection? So we look for the intersection of A and B. So what numbers do A and B have in common? So it looks like they have 2, and then 4 and 6. So we need to find the complement of that. So we go back over to the universal set. and we just take those numbers out of there. So get rid of 2 and 4 and 6, and then list off everything else. So we've got 1, 3, 5, 7, 8, 9, and 10. And that's it. So that's number 4, A, B, C, and D. Now let's see what else we have. I guess let's go up to number 6, and then that'll be it. And we can go back over to the, and then I'll make up another video. Actually, let's stop here, and then I'll just do it page by page. So that's the first page of the probability review. A lot of this stuff can be found in the first 2 sections, I believe. So, just look through those if you need a couple of extra examples. All right, that's it for this one. Now we're going to go on to the second page.